So I'll initialize a new Go project and then go ahead and create the main.go file, package main, func main, do a little print statement, run it, and there we go. Then I will go ahead and create a makefile with two rules, a build rule to build the app, and the watch rule that uses air to watch over the project files and rebuild the app whenever they change. So if I open my terminal and type in make watch, we see the app is building, we have hello, but if I go to my main.go file and change this to hello world, save it, the app rebuilds, and we got a new message here. Now we'll need a router, so I'll do mux equals http new servmux. We'll also need a server, of course, HTTP server. Let's listen to port 8000 and then do a little print statement starting on string, and the string will be the server adder. And then if error, server listen and serve, and the error is not null, we'll do log fatal and pass it the error. I'll go up here and add a route using mux handle func get slash and then use the $sign to make sure we only match the root path. Func, and here we'll render some HTML. And we'll do that by loading a template. I'll do something like chat t from template, and we'll use the HTML template package, must template parse files. Let's say we have a chat HTML file. And then down here, we'll do chat t, execute, pass it the response writer, and data will be nil. I'll go ahead and create the chat HTML file. It will be a simple document, chat, go in the browser, localhost 8000, and there we go. Let's continue with the rest of the HTML. We'll have a list of messages. Let's do a bit of styling here, margin bottom 20 pixels. We'll have a form. This will be controlled by JavaScript, so we don't need the action. Let's say an input name. I'll also add a default value to make testing easier. And let's also style it a bit. I'll do style with 50 pixels. Then we'll have a message, no default value, and make it a bit wider, and a button. As for the JavaScript, we'll need references to all these elements. So I'll do const messages, document query selector, bound messages. We'll have name, message, and form. And the form is an element, not an ID. Now, to be able to send and receive live messages, we'll need a socket, a new WebSocket. This will be socket localhost port 8000/ws. We don't have this endpoint just yet, we'll add it later. Now, the socket can have a bunch of event listeners. We can have on open, and we'll just console log on open. Can also have on close, on error, and this will take in the error, which will log. And the most important one we have on message. And this is called whenever we receive a message from the server. Here we'll take in the event. We'll create an element using document create element. We'll make it a div. We'll set the element in our HTML to the event data, which will be the message we get from the server. And then we'll do messages append element to add the message in the messages list. Finally, for the form, we'll do form on submit, and we'll have an event here on which we'll call event prevent default to prevent the page from reloading. Then we'll compile a message. We'll do bold, name value, and then we'll have message value, and then we'll send it through the socket. finally, let's also reset the message value to an empty string. Now, if I go into the browser and refresh, we have the form here. If I open up the DevTools, we have WebSocket connection failed. Well, because this endpoint doesn't exist yet. Now, to create and manage WebSockets, we'll use the Gorilla WebSocket package. I'll go down here and grab it. Go to my main.go file and add the new endpoint for WebSocket. And here we'll need to upgrade the HTTP connection to a WebSocket. And to do that, we'll need an upgrader, which we can grab from the WebSocket package. And then here we can do con error equals upgrader upgrade, and we'll pass it the response writer, the request, and any additional headers we might want to pass. If we get an error, we'll simply return HTTP error, pass it the response writer, the error message, and set the status to 500. Otherwise, we can continue and try reading from the connection. Now, this read message method returns a message type, the message itself, and the error. We can ignore the type because it will always be a text message. And now we could do this, but if we think about it, whenever we hit this endpoint, we upgrade the connection, we try reading one message, and then we exit the function. And what we need to do is to continuously be reading messages. So we need a for loop here. And we'll continue reading messages until we get an error. So if error is not nil, we'll log it, return, and this will exit the loop, and then exit the function. And then down here, we can also print the message for now. If we go back in the browser, refresh, enter a message, and check the terminal, we can see the message appearing here. Now, to send a message from the server to the browser, we can use the con write message method that takes in the message type, in our case WebSocket text message, and the message itself. This, of course, will return an error, and just as before, if we get an error and the error is not nil, we'll log it and exit the loop. Now if we go in the browser, refresh, and type in a message, we'll see it appearing here. That's because we are essentially sending the message to the server and the server sends it back. And because we have this on message event listener here, this will create a div element with the message we get from the server and append it to the messages list. However, if I'm to go in the browser and open up a new tab and say this guy is Jimmy, hello Timmy, Timmy will not see the message. So the next thing we need to do is make these two guys talk with each other. And to do that, we'll need a list of connections, or better said, a list of clients. So I'll go up here and create a client struct that will simply have a connection. Then down here in main, we'll create a clients list, which will be a map of client pointers and Boolean values. Then down here in the WebSocket endpoint, we'll create a client, pass it the connection, and then add it to the list. We'll do clients, client equals true. Then we'll update this to client connection. And to write the message to all the clients in the list, we'll just loop through the list. We'll do for client equals range clients, and then have this client write message. I'll go in the browser, refresh. Here we have Timmy, here we have Jimmy. Hey Timmy, and the message appears here. And same, if I write something here, the message is sent here. But if we are to add like a third participant, so let's say localhost, and this one is George. Hey guys, the message appears here and here. But if George is to leave the chat, and these two guys continue talking with each other, at some point the messages will not appear. And that's because if we go back here, we are looping through the clients, write a message, But if we get an error, we exit the loop. And because George left the chat, that will give us an error. We'll exit the loop before being able to send a message to Jimmy here. So what we need to do is make sure we always clean up the clients list. What we can do here is defer a call to a function that will simply first close the connection and then remove the client from the list. So when we get an error here, this loop will exit and then call this deferred function, which will close the connection and remove the client from the list. So the next time we'll loop here, we won't be getting an error. Let's go and try and reproduce the problem. So I'll open up a new tab, localhost. I'll leave the same names, doesn't really matter. We see the messages appearing everywhere. And if this guy lives, these two can still chat with each other without any issues. We still have problems though. If there is a client whose internet connection is slow, that will affect all the other clients in the list. So imagine we are looping through this list, we stumble upon a slow client, all the remaining clients will need to wait until this client finishes writing. Let me demonstrate. I'll go to client and add an is slow field, which will be a boolean. And then here where we are creating the client, I'll set is slow to rand. We'll use the math rand package. Int n, let's say 3 equals to 0. So roughly 30% of the time is slow will be true now. And if we go here and say something like message equals message, and then if client is slow, we'll slow down the time with 2 seconds. And then we'll also adjust the message. So we'll do a message, append message, let's say slow. And then down here, we'll send MSG, right? Now, if I go in the browser and open up a new tab, localhost 8000, let's say this one is George, this one is Timmy, and this one is Jimmy. Let's see if we have a slow client. And look at this, all of these are slow. Let's refresh. So now let's see if George is slow. No, George is not slow. So right now, Jimmy is the only slow one. So if Jimmy sends a message, slow as fuck. Right? But if Timmy or George send a message, they should be able to talk with each other like really fast. But they don't. And that's because Jimmy here is in the middle, slowing down all the other clients in the list. To fix this, we need to separate reading the messages from writing the messages, and each client should handle their own writing. And to do that, we essentially need to centralize all the messages, and then from that central point, send the messages to the clients, and then each client should write their own messages. The first thing I'm going to do is create a new struct, and I'll call this hub. And this will be in charge of managing the clients list and the messages. So we'll have clients, which will be a map of client pointers. We'll have a register channel of client, and then an unregistered channel. Down in main, we'll create a hub that will have clients, register, which will be a channel of client pointers, and unregister. Then, when we create the client, instead of adjusting the clients list manually, we'll do hub, register, and send it the client. And then down here, we'll do the reverse one. We'll do hub, unregister, and send it the client. Now, to listen to these channels, we'll create a method. Let's say run, and this will do a for loop with a select statement. We'll do case client when it comes from the hub register channel and when it comes from the unregistered channel. When we register the client, we simply need to add the client to the list. When we unregister, we close the connection and remove the client from the list. And now this method will run in its own Go routine. Now to centralize the messages, we'll add a broadcast channel, and then each client will send their own messages to the broadcast. So we'll do a function. Let's say read, and this will essentially do this. But then to send a message to broadcast, we'll need to have a hub reference in our client. So I'll go here and say hub. And then here we can do client hub broadcast and pass it the message. But if we get an error and exit the loop, we should do a defer call to a function that will send to unregister. Let's go ahead and make sure we had a broadcast here. So this will be a channel slice of bytes. And then down here where we create the client, we should pass the hub reference. And finally, we'll call go client read. And this will read the messages from the client and send them to the broadcast channel. But then the broadcast channel should send the messages to each client. So we'll go here and listen to the broadcast channel. We'll receive messages here and then loop through the clients and pass them this message. For that, we'll need to have a channel in client. Let's say send. So this can now do client send and pass it the message. We'll go down here and make sure we initialize send as well. And then we'll create a write method to do the message writing. So let's grab this and we'll do func client write. And this will essentially read from the send channel and write the messages. So we'll do message, okay, because we'll check if the channel is still open. And if it's not okay, we'll simply return, which will exit the loop. Otherwise, we'll continue writing to the client connection. Just as before, if we exit the loop, we should defer a call to hub unregister and send it to the client. Now we can go down here and remove all this, and everything should work just as before. Let's test. Refresh, 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 send a message, and it works. Let's now introduce back the delay. So when writing, we'll go here and do if client is slow. We'll sleep for 2 seconds. Let's adjust the message. Go in the browser, refresh. Let's say George, Jimmy, slow anyone? So all of these are slow. Let's try again. George. George is fast, all right. Let's say Timmy is slow. Timmy is now fast. So Timmy and George are fast, Jimmy is the slow one. But as you can see, the problem isn't fixed. So George is sending a lot of messages, but Timmy is slow to receive them. That's again because Jimmy here is slow as fuck. The reason why the problem isn't fixed is because we are reading the messages, right? And pass them to the broadcast channel. And then the broadcast channel sends it to each of the clients' send channel. But this right here, if send is an unbuffered channel, this call is blocking. And even if send was a buffer channel and the channel was full, this will still block, which means it slows down all the other clients. To fix this, we need to make this channel a buffered channel. And this will sort of fix it. So if we increase this to 500, the chat will be fast as long as the send channel stays under 500 messages. So if I send here, You see, this Timmy here is slow, these two are fast, but these two can still talk with each other pretty fast until this Timmy hits 500. When this guy hits 500, it will also slow down the chat for the other guys. So if we can reduce this to, let's say, 5 messages, and let's see if we have a slow connection. Okay, this guy is slow. So these two can talk with each other pretty fast as long as this one stays under 5 messages. So if I write a message, you see it appears instantly here. So it's instant. But if I go really, really fast, like more than 5 messages, things will slow down, right? It's now slow again. So we've kind of fixed the problem, but not really. To completely fix the problem, we could be generous and say something like 500 here. And this will give this Timmy slow guy enough time. But if 500 isn't enough, we should just kick Timmy out of the chat. To do that, we'll go here and do a select. We'll do select case when we receive a message, and we'll set a default. So if we can't do this, the default will be, well, get out of here, right? We'll do this. Here we should also close the send channel. So if this channel is full, we reach the default case where we should spin up a Go routine that sends the client to the hub unregister channel. Right, so we are being quite generous to allow send to hold up to 500 messages before being kicked out. To test this, I'll go down here and reduce this to 5 messages. Go in the browser, see if we have a slow client, and we do, this one right here. And this one is allowed to stay here until it hits that threshold of 5 messages. So you can see he is allowed to chat, hey. But if the chat goes really fast, this guy will be kicked out because he's too slow. So if we go more than 5 messages, he's being kicked out, right? So he can no longer type messages. He's out. Otherwise, it will just slow down the experience for all the other clients in the list. So just to reiterate, the idea is we read messages from the client and push them to this broadcast channel. This broadcast channel takes the message and pushes it to the client send channel, which is a buffer channel of, let's be generous, 500 messages. And then on the write method, we'll listen to this channel and send a message. However, if the client is slow, at some point, we'll just have to kick them out of the chat.